Well, friends, I have intentionally kept my camera off because of the bandwidth issues. We are discussing in depth regarding the TCPIP model, and in one of the videos, we have also compared the TCPIP model with the OSI model. So, the salient features of TCPIP model that we have seen is that the TCPIP model was developed prior to the OSI model. That is the first thing. The second thing is TCPIP model is not exactly similar to OSI model. You can see in the slide that there are many differences between the TCPIP and OSI model. The third thing is that TCPIP model consists of either you can describe the TCPIP model as four-layer model or five-layer model. Both the options are there, uh, but we would like to go for five-layer model. The description of five-layer model. It consists of the application layer, the transport layer, the network layer, the data link layer, and the physical layer. Now, if you see uh, here also the description is there, the physical layer, the data link layer, the network layer, the transport layer, and then the last one is the application layer. So here you can see the first four layers, that is physical layer, data link layer, network layer, and transport layers. They provide the physical standards, network interface, internetworking, and transport functions. So in this way, the first four, that is the physical, data link, network, and transport, they provide the functions like physical standards, the network interface, the internet working, and transport functions. So these four layers represented in the TCP/IP model by a single layer, the above four, they are called as application layer. Okay. So the next one, that is session layer, presentation layer, application layer, all together they are merged and they are called as application layer in TCP/IP model. Yeah, you'll find that the TCP/IP model is a hierarchical protocol made up of interactive modules, and these interactive modules they provide specific functionality. For instance, the physical layer it has got protocols that provides physical functionality like the voltage levels, the BPS, or the bandwidth, and so on. The network layer, for example, there are inbuilt protocols like ICMP, IGMP, and so on. So we are going into the depth of all these things. So this slide is more important, and this gives in-depth information regarding the TCP/IP model. So in this particular TCP/IP layers, the network access layer is very important, and network access layer, in fact, the network layer uh, is the combination of physical layer and data link layer, which is defined in the OSI reference model. In OSI reference model, we define the physical layer and data link layer. Okay, here you can see the physical and data link layer of the OSI model. It is combined into the network layer, and which is the lowermost layer in the TCP/IP suite. Now, this particular network layer it defines how the data should be sent physically through the network. How the data is basically sent over the network. So that is decided by the network layer. Now, this layer is also responsible for transmission of data between two devices on the same network. So, if two devices, for instance, in Shivaji University network, I have two machines in the electronics laboratory. So, those two machines, those two nodes, they are onto the same network. So, this layer decides basically how the data should be sent on the two, because then the data did not go out of the network and the extra routing and other things can be saved. So it decides how the data is to be sent on the two devices on the same network. Actually, the functions carried out by this layer, you can see here what is the function, because we have already seen one diagram in which there is an encapsulation and headers are added. So these functions carried out by this layer are encapsulating the IP datagram into the frames. Again, I repeat, encapsulation of IP datagrams into the frames, and those frames are transmitted by network and mapping of IP addresses into physical addresses. So these two functions are very important. IP datagrams, and those IP datagrams they are converted to frames by adding the headers, and then Another important function of this layer is mapping the IP addresses into physical addresses, the MAC addresses. Now, the protocols used in the network layer. So, protocol you can see in the network layer. The protocols used in the network layer, those are Ethernet, token ring, or there is a protocol called as FDDI, which we'll see in the last chapter, X.25 frame relay. So for your information, these protocols are very important. The Ethernet, token ring, FDDI, X.25 and frame relay. Uh, the another layer which is important here is the second layer of the TCP/IP model, that is called as internet layer. So internet layer is the second layer of the TCP/IP model. This layer is also known as the network layer. And the main responsibility of the internet layer is to send the packets from any network. Yeah, actually, previously we have seen transmission and reception of packets in the same network. But now internet layer is taking care of transmission and reception of packets from anywhere, okay, even from the outside the network. So this particular layer, it is responsible to send the packets from any network, and they arrive at the destination irrespective of the route they take, because there exist several routes. There exist several routes, and basically the protocols are written in such a way that the shortest possible path is followed. Here you can see this is the layer. So the main protocol used in this particular layer is the IP protocol. And IP protocol is the most significant part. It is the heart of the entire TCP/IP suite. So, this what are the responsibilities lying with this IP? Here you can see what are the responsibilities lying with IP. The first responsibility is IP addressing. So, this particular protocol implements logical addresses, logical host addresses. These addresses are called as IP addresses. Basically, over the internet, as you know, that every machine has to be addressed. Unless it is addressed, it won't be recognized over the internet, and it won't get the intended data transmission and reception. So the IP addresses are used by internet and the higher layers to identify the device and to provide inter-network routing. Another important thing is host-to-host communication. So this particular layer also determines the path through which the data is to be transmitted. As we have seen in one of the videos, that the shortest possible path, which is free of congestion, is chosen in this particular protocol. The third and important function, the first two functions are IP addressing. The second function is host-to-host communication. The third and important function is data encapsulation and formatting. So IP protocol accepts the data from the transport layer. Here you can see this is the IP protocol, and this protocol, this layer, accept the data from transport. This is the transport. We have seen that every layer has to work with the layer just above it. So here it is getting the data from the transport layer, and it ensures the IP ensures that the data is sent and received securely. So security is one of the most important issue over the network, and that is taken care by the IP layer. Here the data is encapsulated. Actually, IP encapsulates the data into messages. The IP layer, again I repeat, the IP layer encapsulates the data into messages, and this is called as IP datagram. You must have heard the word called as IP datagram. So IP datagram is nothing but encapsulation of data into messages. So that is called as IP datagram, and that is the main functionality of the IP layer. Another important thing where here it's important is so three things we have seen. The first one is IP addressing. The second one is host-to-host communication. The third one is data encapsulation and formatting, which is popularly known as IP datagram. The fourth and most important thing is fragmentation and reassembly, because huge amount of data cannot be sent in one go, as we have seen. So fragmentation is required, and therefore the limit is imposed on the size of IP datagram by the data link layer protocol. So data link layer protocol, it imposes the limit on the size of the data, and this is known as maximum, and this particular protocol is known as maximum transmission unit. So maximum transmission unit is defined by the IP. It's in brief, it is in acronym is MTU. So MTU stands for maximum transmission unit. So if the size of the IP datagram is greater than MTU, that is maximum transmission unit, then the IP protocol will split the datagram into smaller units, so that all the smaller units, they can go over the network, over the local network, right? So the main function of IP is data fragmentation, and this fragmentation is done on the basis of a threshold. That threshold is called as maximum transmission unit, MTU. So if the datagram, that is the encapsulation of data into messages, if it is higher than, greater than the MTU, then the datagram is split into smaller units, and they can transfer over the local network. So fragmentation can be done by the sender or the intermediate router, because router is the device which is operated here, and the router has got built-in protocol just to calculate, just to comparison, and then fragmentation. All the intelligence is built in into the router in the software part, and then as I said, the fragmentation can be done by the sender, either by the sender or by the intermediate router. At the receiver side, all the fragments are again reassembled, because they might have come from different routes, alternate routes, and they are now reassembled into just to form the original message. So original message must have been fragmented. In case it is higher, it is bigger than the intended size threshold, which is defined by maximum transmission unit. It travels through different paths, and then it is reassembled at the receiver based on the number, because one of the important part of functioning is also giving numbers to the packets, datagrams. Another important function of the IP is routing. So when the IP datagram is sent over the same local network, such as LAN, MAN, or WAN, this is known as direct delivery. So direct delivery is nothing but it forms the delivery of the IP datagram over the same network. However, when the source and destination are onto the distant networks, then the IP datagram has to be sent indirectly. So this can be done by routing the IP datagram through various devices such as routers. So here the router comes into the picture. So whenever there are machines, that is source and destination, so they are onto different networks, then the indirect routing is done, and that is also done by IP. Another important protocol at IP you can observe is ARP. So this ARP stands for Address Resolution Protocol. So ARP is the network layer protocol, basically, because it is in the network layer, and this is used to find the physical address from the IP address. So ARP, the Address Resolution Protocol, because there are two addresses, one is logical address and other is physical address. So the ARP is resolving the physical address of the host which is there on the network. The two terms which are mainly associated with the ARP protocol are ARP request. So when a sender wants to know the physical address of the device, the sender will broadcast the ARP request to the network, so that the sender will come to know regarding the physical address of the device. So this is called as ARP request. And in response to the request, there will be ARP reply. So every device attached to the network will accept the ARP request. It will process the request, and only the recipient which recognize this IP address, so where the IP address matching is there, it will send back the physical address in the form of ARP reply. So in response to the ARP request, suppose a sender wants to know what is the physical address of a machine which is connected over the network, there will be ARP request, because there is a protocol which is written for this. And then in response to ARP request, there will be ARP reply, and this reply is nothing but the request will be accepted by everyone, but the machine for which the data IP address is matching is there, that machine will respond with the ARP request, and that too in the format which is required for this. Uh, so the 15 minutes limit is now getting over. So we'll also discuss the other protocols like ICMP, the transport layer protocols, and SMTP, FTP, etc. in the next few videos. Thank you very much.